Okay, so this is going to be reporting category 3, Earth and Space. And what we're looking at here is two things. We're looking at the difference between Earth's rotation and Earth's revolution around the sun. So in this picture here, we have the sun's rays on this side right here. This is the sun, and this is the Earth. And the Earth is actually turning, and so we know that when the Earth rotates, or spins around its axis, that causes day and night. The axis is this imaginary line right here. The Earth is tilted at 23 degrees, and that becomes important on the next slide. But as the Earth turns, the side that's facing the sun will have daylight, and the side that's facing away from the sun will have nighttime. So rotation takes 24 hours or 1 day. And the way that I remember that, and I would write this down on my STAAR test before I ever started taking any of the questions, answering any of the questions, is rodation. Rodation, rotation, rodation, because rotation, turning, spinning of the Earth has to do with day and night. All right, the time it takes for the Earth to revolve around the sun. Well, it takes 365 days for the Earth to complete one. That should be one. And we call that a revolution. A revolution, to revolve, is to go around another object. So, a revolution. And in space, it's when we're revolving around an object that's bigger than ourselves. So, a revolution. However, because of its tilt, the Earth's tilt, and these are your clue words, is tilt and revolution. The sun's rays hit the northern hemisphere longer and more directly in summer than in the winter. When it's summer in the north, it's winter in the south. The equator, however, is really not affected by the Earth's tilt. The equator has summer pretty much all year round because it's receiving the sunlight, the light from the sun, pretty consistently every day all year round. So, tilt and revolution are your clue words for seasons. So if I have the sun right here, and that's the sunlight, and it's going this way, and here's my Earth, and it's tilting towards, there we go. The northern half is called the northern hemisphere, north of the equator. And as you can see, this is receiving more of the sun's light. So therefore, this would be summer. And in the south, it's the opposite season in the southern hemisphere, below the equator, south of the equator. So this would be winter. All right, in the model to the left, which hemisphere of Earth is experiencing summer? Well, the first thing I want to do is I want to highlight the important things. So, which hemisphere of Earth is having summer? And I know that that has to do with the Earth's tilt. So, which side is tilting towards the light? And in this case, we're using a light bulb as the sun. And so we can see that the sun is hitting the northern hemisphere more directly. So, it would be the northern hemisphere. And if it's north, if it's summer in the north, it is winter in the southern hemisphere. All right, second question. When the Earth, let's get our little highlighter out. When the Earth reaches position T, which is here in the model, which season will Texas experience? Ooh, that's a very good question. All right, so if I've already figured out that this is summer, on this side, then that means that here on S, and here's my tilt, I'm going to have winter in the north because it's opposite seasons, and I'm going to have summer in the south. So we know that we go counterclockwise because everything in nature is pretty much counterclockwise. So right here next to T, I'm going to figure out, okay, what season am I going to be in Texas? and I know that Texas is in the northern hemisphere, so I'm going to sing my little song, winter, spring, summer, or fall. So winter, spring, summer, or fall. And I know that in Texas, I am going to be experiencing spring. Again, that's just drawing it out. When in doubt, draw it out. I have to draw out my seasons to really know what I'm answering. I like this picture right here because it's a really good picture of rotation. So you can see how this whole side is facing the sun. Because remember, we're talking about rotation. We're talking about, you said it, we're talking about day and night. So this side's in day and this side is in night. So Z would be in daylight and U would be in night. X, let's look at X. X is about to have sunrise, isn't it? X is about to have sunrise. It's ending its nighttime cycle and going into the daylight. Okay, which of the following, let me get my highlighter out here. Which of the following best describes days and nights? I know that if I'm talking about day and night, I am talking about rotation. Anytime I'm talking about day and night, I am hearing the word rotation in my head. So, which of the following best describes days and nights? I'm looking for turning. I'm looking for spinning. I'm looking for rotation. Days and nights. Let's see. The northern hemisphere is having days that last longer than the nights. Ooh, this is a tricky question. The southern hemisphere is having days that last longer than the nights. Both hemispheres are having nights and days that last the same amount of time, or both hemispheres are having days that last longer than the nights. Okay, so this is actually a day and night and a season question, because we know that in the summer, right, we have longer days and shorter nights. We know here in Texas that in the summer, daylight can stay out till almost 10 o'clock at night. So, in the summer, we know that the northern hemisphere is experiencing summer here, and the southern hemisphere, which is tilting away from the sun, is experiencing winter. So the northern hemisphere is having days that last longer. Yes, that's true. The southern hemisphere is having days that last longer. No, they're actually having days that last shorter. We know that in the winter we have shorter days. Sometimes in the winter, our nighttime will come at like 4:30 in the afternoon. Both hemispheres are having nights and days that last the same amount of time. No, they're not. The equator would be, but not the hemispheres are having days that last longer. That means they both would be in summer? No. Your best answer choice was right here. That was a great question. It kind of involved both. What is the effect, and let me highlight here, of the northern hemisphere receiving the direct rays of the sun? Well, if the northern hemisphere is having the direct rays of the sun, that means that they're in summer. So the northern hemisphere is having winter? No. They would be having less direct rays from the sun. Northern hemisphere is having spring? No. Fall? No. We know our best answer choice is going to be summer, because in summer you receive the most direct rays of the sun. All right, phases of the moon. This is kind of one of my favorite things. So one thing you have to remember is that it's 3.5 days between each phase, and there are 8 phases. Why? Because there's 28 days in a lunar cycle. Okay, 28 days. Notice the chart. The first thing you've got to do is you've got to find the sun. The moon that's in between the Earth, excuse me, sorry, I'm fighting a cold here. The moon that's in between the sun and the Earth is the new moon. We go directly opposite, and that's the full moon. And we'll talk about that in the next slide. But the most important thing is to remember that there's 3.5 days between each phase, because that's going to come up in just a moment. Okay, how do I draw the lunar cycle? Well, the first thing I have to do is find the sun. Let's put our sun on this side for now. It doesn't matter which side they put the sun on. You just have to find the sun first. Check. Now, here's my Earth. I'm going to make it a little bit smaller just so it's easier for me to draw. So, I'm going to find the moon that's in between the Earth and the sun. Here it is, right here. we know that that is going to be the new moon. Because if I'm standing here on Earth and I am looking at this moon, I can't see it. Because the side of the moon that I see isn't lit. The back side is, but I don't see that side. So that's my new moon. I go directly opposite of the new moon, and that is going to be my full moon. Okay? So that means that if I'm looking at the moon from this side of Earth, I'm seeing all of the sun's rays hitting the side of the moon that I see. That's my full moon. Now I got to find my quarter moons. Remember, everything goes counterclockwise in space. So counterclockwise would be going this way. So my quarter moon is going to be here. This is my first quarter moon. And I'm just going to put one Q here. And this is my third quarter moon. And I'm going to put a 3Q here for quarter moons. I just got my first 4 major phases. Done. Check them off. Now, the hard part to me are remembering those gibbous and those crescent moons. Well, remember, I taught you a little shortcut to that. A, B, C, D, E, F, G. A, B, C, D, E, full gibbous. My gibbous moons are going to be next to my full moons. A, B, C, D, E, full gibbous. My gibbous moons are next to my full moons, which means that these have to be my crescent moons. And I'm just going to label that with a C. All right. Now I got to figure out my waxing and waning, right? Well, if I'm gaining light, if I'm going from a new moon where I don't see anything to a full moon where I see everything, I am waxing on light. I'm gaining. Waxing means to gain. I'm gaining light. And if I'm going from a full moon where I see everything to a new moon where I see nothing, I'm waning. I'm losing light. So we call this waning. The verb wane means to fade away. And so now I have my lunar cycle. And I would actually draw this before I ever started taking any questions on my STAAR test. Okay, so how do I know if I'm waxing or waning? What if they just give me a picture of a moon and it looks like this? And bear with me here because my mouse does not make for the best art, but you get the idea of this moon, and this side's darker. Okay, you get the idea. Now, the first thing I'm going to do is I'm going to draw a line. Let's see if I can draw a straight line. I'm working it through the center of the moon. I'm going to look at the moon that has the most light. So which side of this moon is lit the most? Well, it would be this side right here. Does it make a lowercase d? Let me get my highlighter. I think that would be easier to see. Does it make a lowercase d, the most lit side, or does it make a b? Well, it makes a d, doesn't it? So, I know that the D means dying. And I put that right here for you. The D means dying. It means the moon is losing its light, and that is waning. So I know that this is going to be a waning. And because the moon that is lit is 75% lit, this is going to be a waning gibbous moon. I hope that helps you. This made all the difference for me when I was trying to remember how to do which moons were waxing or waning. If the other side is lit the most, then it would be born, and that means that the moon's gaining light, and it would be a waxing. All right, let's practice. Tides. Tides are actually caused by the gravitational pull, okay, of the gravitational pull of the moon and the sun. The sun comes in play here. It's mostly the moon's gravity because the moon is closer to us, but also the sun's gravity does play a part in this. So let's look at the moon phase at position 1. Okay, here's position 1. Remember when I said to find the moon that's in between the sun and the earth, and that was always going to be your new moon. Okay, your new moon. So if this is my new moon, I know that position 3 is going to be my full moon. And I know I go counterclockwise, so I'm going this direction. Actually, I got arrows. Yay, that helps me. So I know that 2 is going to be my first quarter moon. And I know that 4 is going to be my third quarter moon. Now, I just answered 4 of the major phases right there. All right, so let's look at the moon that's in between 1 and 2. Well, actually, I'm going to go find my full moon. This is my full moon right here. And I remember my little song, A, B, C, D, E, F, G, A, B, C, D, E, full gibbous. So, 3 and 4 are going to be gibbous moons. So I know I've got a gibbous moon here because this is a gibbous moon and this is a gibbous moon. This is going to be a crescent, and this is going to be a crescent. So between 1 and 2, I know I have a crescent moon. And between 4 and 1, I have a crescent moon. So between 2 and 3, I have a gibbous moon. And you can see how I'm sketching this out on the diagram as well. So now I just have to figure out waxing and waning. Well, if I'm going from a new moon to a full moon, I'm waxing on light. I am gaining light. So therefore, this is going to be waxing, and this is going to be waxing. And if I'm going from full to new, I am waning. I am losing light, which means that this is going, we'll put an X here, waxing, and this is going to be a waxing, which means that this is waning. And this is waning. And you can see how I am using the diagram and I'm labeling to help me remember things. Also, I already did a lunar cycle, right? Before I ever start taking my STAAR test. Just be careful when you compare. You've got to check where the sun is. That's so important. The time it takes for the moon to revolve around the Earth is the same amount of time it takes for the moon to actually rotate. And so it is 28 days. All right, good job. All right, let's take a look here. I'm going to get my highlighter out. A student's making a model of the lunar cycle. What 2 terms does a student need to include which tells you the direction of the movement of the moon? Well, includes the direction of the movement of the moon. So what can I get rid of? Well, I can get rid of east and west. Direction of the movement of the moon. It would be not orbiting and rotating because they go the same 28 days. Towards and away from what? I don't know. There's no reference point there. But definitely I could use waxing and waning because I know waxing is going from gaining light. That's going from the new moon to the full moon. And I know waning is full moon to the new moon because I'm losing light. Okay, what lunar phase directly follows waxing crescent? Ooh, well, let's see. I know that I'm going to go back and look at my picture. Okay, so a waxing, they say waxing crescent, right? Well, actually, I don't even have to do that. I can label this here. So let's just do that. Let's just label what we're looking at. This is going to be a new moon. This is going to be a full moon. And I know if I'm going from new to full, this is going to be first quarter. And this is going to be third quarter. That's my 50% lit moon. All right, so if I'm going from new to full, I know I'm waxing because I'm gaining light. Okay, which means this will be waning and this will be waning. And I know this is a crescent because 25% of the moon is lit. 75% of the moon is lit here. It's a gibbous. It's also A, B, C, D, E, F, full gibbous. So the gibbous moons are by the full moon. So what comes after a waxing crescent is going to be first quarter. And that's exactly how I solve it. All right, which diagram? Let me get my highlighter back out. Which diagram best represents the next phase that will occur in this sequence? So let me start labeling. All right, I have a full moon here. And I know that a gibbous moon is always next to a full moon. I know that this is going to be a quarter moon. and my full moon is always traveling back to my new moon. So if my full moon is traveling back to my new moon, I am waning. I am losing light. So this is going to be a waning gibbous, which means this is third quarter, which means that this is a waning crescent. And once I've hit a waning crescent, let's see, I go right back to are you ready for it? A new moon. And I'm going to color all that in. I could also have done this by saying this is 3.5 days, this is 3.5 days, that's 7 days in the cycle. So 3.5 and 7 days, and I'm coming back around halfway through the cycle. So, new moon is going to be the best answer choice here. Okay, what's the name of the phase of the moon in this picture? Ooh, now I get to draw my line down the center. So I'm going to draw my line down the center. And then I'm going to draw the side that's lit the most. This is a B. It looks like the lowercase b, and I know that that means born, which means that I am gaining light. I am gaining light, so therefore I'm going from not a new moon, not a gibbous moon, I'm going, I don't like the word half moon there. I'm actually going to first quarter. This is a quarter moon, first quarter moon. All right, let's talk about the universe. The nebula. Nebula are huge clouds of dust and gas, and that is where stars are formed. Stars are formed in nebula. Okay, and this is a nebula right here. Asteroids. Asteroids are just large rocks, and they revolve around the sun. Comets are made of ice, dust, and small rocks, mostly ice and dust, and they also revolve around the sun in our solar system. And a star. We have one star in our solar system, but there are billions and trillions and gabillions of stars in our universe. And a star is made up of hydrogen, and when that hydrogen smashes into each other and takes protons, it becomes helium, and we call that fusion. And that's what releases a lot of energy, including light. Galaxies are made up of stars. Okay, they're held together by gravity. Everything in our solar system is held together by gravity. Everything in our universe is held together by gravity. So, we have three types of galaxies here. We have what's called a spiral galaxy, makes those really pretty shapes with the arms coming off of it. This is called an elliptical galaxy because it has that nice egg shape. It's an older galaxy. It doesn't have the arms spiraling off. And this is called an irregular shaped galaxy. It's basically just a huge star cluster. There's no real pretty shape there. And Earth? Well, Earth is a member of the Milky Way galaxy. We're a small galaxy compared to other galaxies. You'll have to pardon my mouse writing here. And we are a spiral galaxy. Actually, we're located right here, our little solar system. So we're not too close and we're not too far away. We're just right. All right, this is the HR diagram, and we use this to classify stars. There's only two things that we can see about stars. We can see how hot they are, their temperature, and by the color of the star. And we can also see how bright the star is. Another word for magnitude is a word called luminosity. It doesn't matter if they use the word luminosity or if they use the word brightness or magnitude. It's how bright the star is, and that is on your y-axis. Temperature is on your x-axis, and you need to be careful here because these stars right here are really hot. They're releasing a lot of energy, whereas these stars are not quite as hot. They're releasing less energy, so we have to be careful about that. All right. And we're located right here on our Milky Way galaxy. So let's look at the question. Which of the following would astronomers most likely measure in light years? Light years is what we use to measure distance in space. Light years is about 250,000 miles per second. Imagine going 250,000 miles per second. That's really fast. And so we use light years to measure the distance between huge distances in space. So between the Earth and the Moon, no, that's 250,000 miles. We don't have to use light years to do that. The time it takes to travel to Jupiter, we can still use miles. The time it takes sunlight to reach Earth, well, it takes 8 minutes for the sunlight to reach Earth. We're going to use distance to measure distance between stars, between galaxies, because they're so far away. All right, we know that this is a spiral because it has that beautiful shape. This is an elliptical because it has that egg shape to it. And last but not least, what was it? Yes, you guessed it. This is an irregular galaxy because it's just stars clustered together. Okay, let's look at this question here, this practice question. What does the HR diagram tell us about the star Betelgeuse? Although I don't think that's how it's really pronounced. But here it is right here. Well, I know that it's very high on luminosity, on brightness, but it's not as high on temperature. So it's very bright. So it's bright, so it has a high luminosity, so that checks and that checks. I can get rid of C and D because it doesn't have a low luminosity. It's very, very bright. It also has a very low temperature, not high. If it was high, it would be over here in the upper main sequence stars. The answer choice is A. And you can see again how I'm labeling. All right, let's practice. Which of the following can be found in galaxies? Well, I know that galaxies are made up of stars. So, I have no idea what a lenticular galaxy and a regular galaxy is, but I know that galaxies are not made up of other galaxies. Dust, gas, and millions of black holes. Not sure about that one. Mini galaxies. I've never heard of a mini galaxy. Never even heard of that, actually. Stars, interstellar gas, and dust, which is nebulas. I know that galaxies are made up of stars, but I don't see stars in this answer choice. Millions of black holes? I don't think so. Gas and dust? Absolutely. That's what nebulas are. That's where stars are born. Your best answer choice? A. All right. Well, I hope you've enjoyed this, and you're going to do great on your STAAR test. We believe in you, so good luck.